So hello again, and welcome to the part two of our section for today, or section 3. So we have been talking about resistors, and the next thing we have to talk about is the push button switches. So just like you would have a normal switch or key, which can be able to put a whole circuit in the on state or an off state. These push button switches are simply buttons that can be able to make two contacts or be able to connect two contacts together so that it can allow electricity to flow through them. So it's simple. You could think, so let's say this is one contact, this is another contact. What a switch will do is we'll be able to get these two things to be able to connect together. And usually we'll have something that would allow that to happen. So for the push button switch we are going to use, or you guys have in your kits, it usually looks like this. And you notice that it has 4 legs, which can be a bit confusing because it has 4 connections, but usually a switch will just have 2, which will be able to switch between on and off states. Now, what we are going to use has 4 legs, and the legs are labeled A, B. So if you look at this diagram here, you notice we have A, B, which corresponds to the legs on the left-hand side of your image, which is A, B. And then we have C, D to be the right-hand side, which looks like this. So if you can sort of picture it, so in the middle you would have this portion, which at the moment is in the up state, which means it's not making contact with these 2 points, which will be able to get these two, which will get this part and then this part connected together, right? So it's useful to know this because you'll be able to use this in different projects and it will serve different purposes. Now, before we go to the example, I just want to say that so in general, there are only 2 electrical connections, and inside the switch package, you would have pins B and C and are connected together, as well as you having A and D connected together. So depending on what you want to use it for, you may maybe be interested in using connections, say A and D together to be able to serve as a simple switch, or use B and then C. From experience, I've noticed that explaining the switch this way, or just going over which pin means what, may not be clear. So usually in an actual example where you build a circuit and then you make the connections, that's usually much easier to understand. So talking about that, so this is our example circuit, and we have a separate recording of how you could do this simple circuit. Use 2 of your switches, which one will serve as the on switch, which will be able to make the circuits turn on, and then the other switch will be able to get the circuit to turn off. So this is an example which we have a recording for, which you will see shortly. Now, I just want to say that apart from this, well, this part of the setup, which has the breadboard and everything, that will remain the same for you. The only difference is instead of the Arduino Mega, which we are using in this case, or which in this image we are using, we would rather have the Cansat payload module, which is the Aqua, to be able to do this example. So look forward to that example or that video, which we will share with you shortly. Now, having talked about the push button switch, we can now move on to talk about a passive buzzer. Now, for a passive buzzer, it's one of the simplest component that you can use to introduce some form of sound to your project. It's being used usually in countless number of electronics system applications. Sometimes it's used as an alarm. Sometimes it's used to play specific melodies to bring fun to projects. Now, I'll just go over the working principle of the buzzer, and then we can look at the features or how it actually looks and what you need to take note of. So in general, it uses something called the pulse width modulation to generate an audio, which makes air to vibrate. So remember, sound is produced by when we have vibration. So usually you can have vibration in, could be in a material, it could also be vibration in just the air. And for a buzzer, it does that by making vibration in the air, which is all within this passive or within this buzzer. Now, because it's this audio that is generated is at a specific frequency. So, for example, it sends a pulse of a specific frequency. In this case, it's about 523 hertz, and it can actually be able to use that to generate an alto do. So if you remember the do, re, mi, fa, sol, la, ti, do. So those are all at specific frequencies, and you can actually have, or the buzzer can actually be able to send a pulse corresponding to an alto do, a re, a mi, fa, sol, or any of these various notes, and produce that associated sound. So it's a very, very cool component to have, because it brings it brings your project alive in terms of making sounds that are interesting. Now, having talked about what it is and what it does, we can go on to talk about how it looks like. So the passive buzzer is a component which is polar, and what that means is that it has a positive leg and it has a negative leg. So in general, it just has two legs, and it's polar, one positive and one negative. Now, there's a way you can be able to tell which leg is positive and which leg is negative. So on top of the buzzer, you notice there's a plus sign, and that plus sign will correspond to one of the legs, and that tells you that that leg is the positive leg, and then the other leg or the opposite leg will be the negative leg. Now, this is important because as we have established in some of our other sections, it's important to make sure positive stuff or negative legs are connected to negative legs, positive also to positive parts of your circuit. So one of the examples we would be doing would be to use the buzzer to produce the do, re, mi, fa, sol, la, ti, do melody using a simple code that we will write in our Arduino IDE. So the setup will look like this, and in this case, the red leg represents the positive part of the buzzer, and then the black connection here will indicate the negative leg. So again, similar to the component we discussed previously, instead of the Mega 256 Arduino Mega, you would have the Cansat payload instead for your projects. So again, there's a separate recording of how this project can be done, which we will share with you shortly. So the next component that we would address or talk about is the trimmer, or sometimes called the trimmer potentiometer. Now, if you know a variable resistor or a variable resistor, standard resistors would usually have not a constant, but they will have they will have a resistance which is constant, right? So for example, you can have, let's say, a 250 ohm resistor or a 1 kilo ohm resistor. So that value is constant, it doesn't change. Now you can also have, the idea behind a trimmer or a variable resistor is that instead of having a constant value as its resistance, you can actually be able to change between the resistances, which means it can be variable, right? Now that is the same idea behind the trimmer potentiometer, because it's essentially a resistor whose value can change between a set point. And what that means is that we can be able to fine tune parameters such as our voltage, the current, and then the resistance. And depending on what project you use this in, it can actually, vary a few things in the project. So, for example, if you use a thermal potentiometer, or if you have a project where you have, let's say, an LED in a circuit, and you want to change how bright the LED would be, you can actually use a thermal potentiometer, or essentially a variable resistor. And depending on what resistance you have, which can be, of course, fine-tuned using the resistor, using the resistor you have, then you will be able to change the brightness of such an LED, which is one of the things we would be doing in this project. So just a few other things. It is made of a resistive element, which means something that does not allow current or voltage to flow through it easily. And as you can see on your left-hand side, sorry, right-hand side, image of the thermal potentiometer, which you have in your case. So this is also a simple circuit of a project, which includes a normal resistor, which you have somewhere here, an LED, and then the thermal potentiometer, which, like I said, we do have a separate video on this, which you can be able to use just to be able to understand how the thermal potentiometer works. Similar to the previous component, instead of this microcontroller here, you will actually be using the Cansat payload controller or NACOA to ask your microcontroller to replace this component. But we do have a separate video for this, which you can follow on how to do. So so far that's what we have for you today. We have been able to cover how to find the resistance of a resistor by using the color code method. We have gone through what a push button switch looks like and what it is, and what you need to know. We have also talked about a buzzer and what a buzzer is, which is something that produces sound that we can use in our projects. And finally talked about the thermal potentiometer, or the variable resistor in some sense. Now, there are several assignments that I have showed, so I'll just go over quickly just to remind you of the assignments for the resistor. So you need to find the resistance of these resistors. So we have a 4-color band, a 5-color band, and then a 6-color band resistor. So try your hands and see if you can be able to find the resistance of these various resistors. And then, of course, like we have said, this example circuit for the push button switch, this example for the passive buzzer circuit, and also this for the trimmer or the potentiometer circuit. We have all these recordings in a separate video, which you can follow on how to do this. So until we meet next time, thank you so much, and hopefully you enjoyed the section. Of course, if you have any questions, please send this to the WhatsApp page, or you can send it to the corresponding email, which has been shared with you. So thank you so much, and see you soon. Bye-bye.